Hey guys, today we're going to see the 973rd problem and Leetcode, which is the K closest points to origin problem. As you can see, this is a medium problem, and this is a problem which is mostly asked in Google interviews. So it has a higher frequency of getting asked in Google interviews. So if you see, we have a list of points on the plane, find the K closest points to the origin. So you will be given certain points, and you will be given a number K, and so origin is nothing but 0 comma 0, right? And from 0 comma 0 you have to find the k closest points to it. So the distance between 2 points in a plane is Euclidean distance, and Euclidean distance is nothing but the square root of the difference between x coordinate sum plus the difference between the y coordinate sum. Okay, so you may return the answer in any order. The answer is guaranteed to be unique except for the order that it is in. So for example, let's take a look at this example. Okay. So points given are 1 comma 3 and minus 2 comma 2, and k is equal to 1, which means you have to return only one point which is closer to the origin. Now if you calculate the distance between 1, 3 and the origin, it is 1 minus 0 root of square root of 1 minus 0 the whole square, which is 1, plus 3 minus 0 the whole square. So root of 1 plus 9, so it is going to be square root of 10. And the distance between minus 2 comma 2 and the origin is square root of 8, because square root of minus 2 comma 2 minus 0 the whole square, which is 4, plus 2 minus 0 the whole square, which is 4. So 4 plus 4 within the square root is going to be square root of 8. Okay, and so as you can see, square root of 8 is going to be lesser than square root of 10, which means square root of 8 is closest to origin than the square root of 10, which means minus 2 comma 2 is closest to the origin, and that should be returned as the output because k is equal to 1. Let's take a look at the second example given. So if you see, the points are 3 comma 3, 5 comma minus 1, and minus 2 comma 4, and k is equal to 2, which means you have to return 2 points which are closest to the origin. And so let's see. So 3 comma 3, when you calculate the Euclidean distance of it from origin, is going to be square root of 9 plus 9, which is going to be 18. And then when you consider this, 5 minus 25 plus 1, so it's going to be 26. So remember, this is 18, this is 26. And if you consider minus 2 comma 4, minus 2 comma minus 0 the whole square plus 4 comma 4 minus 0 the whole square, so which is going to be 4 plus 16, which is going to be 20. So this is 18, square root of 18, and this is square root of 26, and this is square root of 20, right? So out of this, the least distance points from origin are going to be 3 comma 3 of distance square root of 18, and minus 2 comma 4, which is of square root 20. So these 2 points will be returned. So the order does not matter, so the answer minus 2 comma 4 and minus 3 comma 3 would also be expected to be accepted. Okay. So as you can see, you know, whatever points have distances closest to the origin, those points are only going to be closest to the origin. So this screams of sorting, and you can see, and they are taking the least distance, and basically least distance points are returned. Okay, so this is clearly a sorting problem. So what we are going to do is we are going to calculate the distances of every point from origin. I'm going to sort it. So in that way we will have the first k points from the array. We can take it as the least distances from the origin. And if you see at the right hand side, we are just asked to pass in and we are just asked to return a two-dimensional array of these points. So the first dimension is obviously going to be k, right? So k number of points, and the second dimension is obviously going to be 2, because every point has 2 coordinates. Okay, so let's quickly see how we are going to do that. So for example, I will have a distance array. Okay, so let us quickly have a distance array, which is, for simplicity, I'm going to say n, or total number of points is going to be points dot length. Okay, and also new end of n, so now those many number of points, and we are calculating distances of those points. So what I'm going to do is, for int index is equal to 0, index is less than, write it over the points array, and index plus plus. So not for the points array, we've already captured its length, so we can directly say n. And if you see, this is a two-dimensional points array, so which means every index, every first index of it is denoting a two coordinate point, which is represented as a two element integer array. Okay, so what you can do is distance array of index. So this is going to be the distance. So I'm just going to call dist of points of I, of index. So points of index, so for this example, if you see 1 comma 3 and minus 2 comma 2, so points of index is going to be 1 comma 3. So we're going to calculate the distance between 1 comma 3 from the origin. So I'll have a helper function which will calculate the distance. For simplicity, we can just say, we're going to just calculate only the square, because square root, and anyhow in square also we're just taking the square root of the square, so both are going to be apart by the same ratio. Okay, so what we are going to do is return array of 0 will be your um, x coordinate, and anyhow we are subtracting it from the origin, which is 0, so we can simply ignore it, and we can say array of 0, array of 0, and then plus array of 1, and then into array of 1. So we've got the Euclidean distance, right? By the end of this loop, we would have got the distances of all arrays. So which means for this we would have got root and 10, and for this we would have got 8. Now let's sort it. Arrays dot sort of distance array. Okay, the array has been sorted, so you will get 8 comma 10, and k is what? K is 1. So what we will do is, in the case of k is equal to, in this case it's just you have to return only one element. In the other cases you have to return k depending upon whatever conditions entail. So what I'm going to do is, I'm just going to have a resultant array, we'll call it as result equal to new int of so how many number of points are required? K. So that will be your row length, and then number of the second dimension is of length 2, because every point is a two coordinate integer array. Okay, so what we're going to do is, in this sort array, suppose k is equal to 2, which means the largest value that you can have, it will be at distance of k minus 1. So I'm just going to take, in order to capture the points to be returned, I'm just going to say the largest um, dist value, this distance value, right? It is going to be from distance array a minus 1. This is the largest value that you're going to return. So what I'm going to do is, I'm just going to iterate over this points array again. Index is equal to 0, because now I have to capture the points. So index is less than n, right? Index plus plus. Okay. So if distance, I will use the same dist function. So if dist of this points, just checking if this distance of this points, if it is less than or equal to our largest distance value, then it means a candidate point in our result, right? So in this case, we will say add it to the result. So we'll have another one index, let's say um, final index, okay, equal to 0, and also what you will do is result of final index is going to be points of index. We're just going to append those points and we're just going to return the result. Okay, so for example, if you consider the example 2, 3 comma 3, 5 comma minus 1, and minus 2 comma 4, so you would have got the distance array of 9 plus 9, which is 18, and 26, right, and then 4 plus 8, I mean 4 plus 16, which is going to be 20. So once you sort it, right, after arrays dot sort, this array is going to look like 18, 20, and 26. Now the largest value that you can return is k minus 1, because k is what, 2 here, so k minus 1 is going to denote the largest value, just 20, because this is 0 indexed array, right? So the largest value is going to be 20, and so we are iterating over the points array. 3 comma 3, its distance is what, 18. 18 is less than or equal to 20, of course, so you can add it to the results of final index. Plus plus for the next iteration, because we're iterating over the index array, and this final index for keeping the sanity of the resultant arrays index. And then you will come to the next index, and the next index is what, next is actually 5 comma minus 1, so index is actually 1 here, right? And if you consider this points is actually 26, and 26 is not less than or equal to the largest distance value, so we'll ignore it. And index 2 will be actually minus 2 comma 4, and if you calculate the distance, this is going to be 20, and which is less than or equal to the largest distance value. So now we will increment result of final index, which is 1. So at result final index, we're just putting points of index, which is minus 2 comma 4. So hope it's clear, guys. So let's quickly go ahead and run this problem and to see whether it is accepted or not. It's accepted. Let's submit this problem. Yeah, it is a successful submission. So as I said, this is a problem which is frequently asked in Google interviews, and it's a medium problem. Its frequency is greater. So basically, you're employing a sorting algorithm, then will sort. So the complexity is going to be O of n log n, because you're applying the sort, and rest is your calculation of the distance is O of n. You're iterating over the array only once here. And then to collect the points which satisfy this condition, to collect the k closest points, we're iterating over the array again. So this is going to be O of n, but then O of n log n is greater than O of n, so the total complexity is thus O of n log n. So I hope you like this video. So if you want a recap, so we're just calculating the distance of all the points, and then we're sorting the array based on the distance, and then we are calculating what is the distance, largest distance value among these k neighbors, and based on that we will collect the points which satisfy the condition that the distance is less than or equal to the largest distance value, and we return the result. Okay, thank you guys, bye.